guys, you're welcome to today's class. I want to believe you guys are doing very, very fine. Now, please, very, very quickly, if you are writing JUPEB, you are writing the JUPEB exam, okay, for 2024, or you are a science educator, or you are a chemistry teacher, and you are in charge of the JUPEB student for this year, then you need to pay maximum attention to this video. Of course, I would have done the practical like the way we used to do it, but I've been busy, and even the SWOT analysis too, the SWOT are not readily available. I don't have them, so that's why I had to do this. But trust me, if you can listen to this video, you carefully watch this video, then the JUPEB questions for 2024 should not be a problem. So if you are just watching this YouTube channel for the very first time, kindly subscribe to this channel and turn on your notification bell so that when I upload any video, you are going to be notified. So today, very quickly, let's actually talk about the JUPEB Chemistry Practical. The JUPEB Chemistry Practical. Very interesting. I love the analysis too, and I want you to pay maximum attention. So this is the JUPEB Chemistry Practical for this year. Okay, now I want you to pay attention. I'll do something very, very quickly now. I'll just the instructions for chemistry educators that are in charge of JUPEB. The instructions for this year, I'll display that on my screen now so that you know where we are actually coming from. So this JUPEB Chemistry Practical, guys, pay maximum attention. I've had a lot of calls, I've had a lot of messages from the JUPEB students. A lot of them have pleaded with me that I just need to do something, and I see it as, I see the love. I see a whole lot of them want me to just say something about the JUPEB exam for this year. So, and that's the reason why out of my busy schedule, I just had to do this. And trust me, this analysis is going to be 75% correct. So please pay maximum attention to this. Take your pen, take a jotter, and jot a whole lot of things, and you are going to use that as a study guide for the exam. It's going to be simple, very simple. So guys, pay maximum attention, and at the end of the video, I'm still going to be showing you some of the things you need to know, so that when you see all these things on that day, you just know, oh, these questions are easy and you will not find it very difficult. This is Chemistry Hangout, and you're welcome to today's class. So let me show you the chemistry exam instructions for this JUPEB exam, so that you know what I'm analyzing and where we are coming from and where we are going to. So let me display that now. So now look at my screen saying Chemistry Exam 2024 Instructions to Practical. In addition to the apparatus and reagents available in the institution laboratory, there's to provide you with all this. The chemistry instructor there will do this. 50 centimeter cube burette, pipette, and the rest. But where we are interested in is the question 1. Go to the question 1. They said 150 centimeter cube of HCl labeled A, which means you are working with the acid HCl, that's hydrochloric acid, and the base, you are working with sodium carbonate, Na2CO3. Very important. So these are what you are working with, HCl and sodium carbonate. Okay. Now let's go to number 2. For the SWOT analysis, you are working with P. They said is ammonium sulfate. Q, they said is iron 2 sulfate. S, they said is what is copper sulfate. Okay, so sit down, guys. Take a seat and let's do the analysis of this. Okay, let's get started. For the titration now, for the titration, you are working with HCl and Na2CO3. Okay, this is the 2 reagents we are working with, HCl. So what are those things we need to note here? What are those things we need to note? Number 1, you must know this is an acid-based titration. This is an acid-based titration. And if you are used to my channel, there are a lot of acid-based titration practical on this channel. I'll drop some in the comment box section so that you can watch that. This is an acid-based titration, okay? That's what you need to know. And we need to know that our HCl is a reaction between HCl and sodium carbonate. That's a strong acid, HCl, and a weak base. So we have the equation of reaction. The equation of reaction is going to be, the equation of reaction here is going to be HCl, okay, aqueous plus Na2CO3, that will be aqueous. To please know all this, you can be asked to write the equation of reaction. Very important. This is a JUPEB exam, so you should understand it's a bit of an advanced exam. So we have NaCl plus H2O plus CO2. This will be aqueous, this will be liquid, and this will be gas. So let's look, is the equation balanced? No. So we have 2 here, right? So from here, hydrogen, is 2 here, right? So we can have 2 here, 2. So 2 hydrogen balance, 2 chlorine balance, 2 sodium balance, 1 carbon like that, 3 oxygen. The equation is balanced. So this equation, and don't forget this very particular, so this is the equation of reaction. Please take note of this. I'm just doing this analysis so that you know these are everything you need to know about this. So when you do this titration, when you carry out this titration, 2 things that happen. Number 1, very important, what happens here, this is a neutralization reaction, right? This is a neutralization reaction. It's a neutralization reaction. And another thing that occurred here in this reaction is what we refer to as ionization. All these questions are questions that can be asked. Now, what are the reactions that occurred here? Number 1, neutralization occur in this reaction. Number 2, ionization occur in this reaction. And very important, the indicator that we are going to be using, the indicator for this reaction is going to be a methyl orange, okay? And that's because you have a strong acid and a weak base, okay? This is a strong acid and a weak base. Very important. Don't forget our normal acid-base titration principle. When you have a strong acid and a strong base, you can use any indicator. When you have a strong acid with a weak base, you can use methyl orange. When you have a weak acid with a strong, let me write that so that we know. So these are things we need to know going for the exam. They are simple questions. You listen to this carefully and you jot as many points here, then you should not have problem with the exam. So don't forget that we said strong acid, okay, strong acid and strong base. Don't forget we said we can use any indicator, right? So we said if we have a strong acid with weak base, like the one we are asked to use for this year, we are going to use our methyl orange. All these things are informations that we should know. So if you are using a weak acid versus a strong base, right? Don't forget, if you are using a weak acid and a strong base, what do we use? We use our phenolphthalein, right? Okay, so we use our phenol. Okay, we use our phenolphthalein, right? Then if we have a weak acid, right, versus what? A weak base, we can still use any indicator. So note that, so for this titration, the indicator we are going to be using is what? Is the methyl orange. I want to believe this is clear. So very, very important. This is what we need to know about this. Now, what are other things we need to know? According to what is provided, the instruction provided from JUPEB, okay, I think I showed that earlier in this video. For the instruction, based on the instruction provided, the titer value for the titration, the titer value is around a 14.10 centimeter cube. This is around the titer value, but nevertheless, I still expect your titer value, maybe in your various center, depending on what they have actually prepared, to be within 12 to 16 centimeter cube. Anything from this range might not actually get 14, it might not actually get 14.10 or 14.00, you know, that's just the theoretical value based on what is provided. The theoretical value, the theoretical title value is this. So when you are titrating based on a lot of factors, you might not get that. So but it should range between 12 to 16. I think that is fine. So note that. So if you are doing your titration, if you don't know how to titrate, you can check my video. Check this video. I think I'll drop it in the comment box. The JUPEB, that's a guide. The JUPEB 2022, the JUPEB 2022 practical chemistry question. Go and check that. I think I did it on this channel. I'll drop the link too here. Go and check that video. That year they used same acid and same base. For JUPEB 2022, they used HCl and Na2CO3. I did that video. Is on this channel. I'll drop the link, the 2022 practical question, so you can practice with that too. You can check the way I titrated it. Same titration, but the only thing is the title value will change. Okay, so it will guide you. The 2022 chemistry practical will guide you. It's on this channel. I'll drop it. Check the comment box section. I'll drop it there. The 2022 titration analysis is still HCl versus Na2CO3. So check it and check the past questions too. If you don't have that, there is a site that you have all those past questions. If you don't have it, you can comment. Just comment on this very particular video. Comment on this particular video. You can drop your comments in the comment box section. I will drop the link for you where you can get the past questions for previous years. 2022, 2021 is there, so you can just drop your comment. Then I'll drop the link for you. Okay. So, but I'll drop the link for the JUPEB 2022. Just check the comment box section. You're going to see it there. So, this was what they used that year. Same acid, same base. HCl. You can practice with all these things. So, watch that video for 2022. I did the practical live. You saw the way the thing changed, the way I recorded my table. You should know that. If you're a JUPEB student, you should know that. And if you don't know that, if you have been following this channel for some while now, you should know how to report your practical doing the table, bullet readings. I'll drop it. So please note that the only difference is that the title value will change, but the titration remains the same. So check this here. There are a lot of questions there, like volume of, you know, titration question, volume of CO2 liberated at STP is there, liberated at STP, how to get molarity. Don't forget that your molarity, when they say molarity, is still your concentration in mole per dm cube. You know, it's bit of an advance, and sometimes they like changing the term. So I calculated it, the volume of CO2 liberated at STP, molarity, that's mole per dm cube, amount in moles. You need to know how to calculate all these things. Amount in moles, how can you get, probably they wrote Na2CO3. You know, this is the base. You can have S2CO3. How do you calculate for X? Is there. You know, the acid is HCl. They might wrote XCl. How do you get this X? It's on the channel. So get yourself busy with the video. In fact, JUPEB 2022 practical is there. Just check my comment box section. You're going to see it there. So very important. And you can check other titration questions. Okay. Because you need to understand that this very particular question, their aim, know all these things, please. Their aim, they can ask you to calculate. I've talked about this, you know, volume of gas. They can use it to get molar mass too. Molar mass of a particular compound. Maybe they did, I think I explained that earlier. They did something like this, S2CO3, or they have XCl. Do you see that the X now, they have omitted the sodium there. The X now, they have omitted the hydrogen here, so you can be asked to calculate this. Is on the channel. I have a lot of videos. 2021 WAEC. If you go and check 2021 WAEC practical I did on the channel, you see how I calculated X. They are there. There are a lot of titration questions on the channel. So if you check the 2022 JUPEB practical, check the comment box section. I'll drop the link there. It is there. And there is also a site for JUPEB students that you have all these practical questions. If you don't have it, just drop your comment now so that I can send you the link. I'll just copy the link and send to you so that you can access it. The titration question should not give you any problem, should not give you any sort of a problem, because for me it is simple. You have a lot of guide on the channel, you have a lot of questions on the channel. I'm going to still drop the JUPEB 2022 that is similar ACl and sodium carbonate, so I don't think that should give us problem. So guys, just rehearse with that. A lot of things you need to do, but you just have to work personally too, so that you will not find it very, very difficult. So the one that I'm going to be doing is the number 2 now. Please pay attention to this, and that's the salt analysis. I want to believe the number 1 is clear, and if you have any question as regards the number 1 too, you can drop it in the comment box section. I will answer you as fast as I can. So the salt analysis now, let's talk about the salt analysis. They made us understand that the samples, the sample P, they said is ammonium sulfate. The sample P is ammonium sulfate, right? The sample Q, very interesting. I wish I have this salt. I would have, is your iron 2 sulfate, while the sample S is our copper sulfate. So these are the 3 salts you are going to be using. Very fantastic. The reason why I didn't actually do the live video, or I didn't perform it practically, is because I have only copper sulfate salt here. I don't have the iron 2 sulfate salt, and I don't have the ammonium sulfate. I think I've exhausted the ammonium sulfate salt too. But just pay attention to my analysis. If you check the WAEC they did this year, I did the analysis like this, and it was, this salt analysis is very, very simple. In fact, it is simpler than the titration, because all the analysis that will be carried out here, we understand it, because based on the reagents that they have given you, if you check what I displayed earlier, if you check at the bottom of that instruction, you see some of the reagents they ask us to provide. And seeing those reagents, we know exactly what they are going to tell you to test on. If not at least 100%, I can guarantee you that this analysis is going to be 70% correct. So take your pen, please, for this number 2. Take your pen and actually jot a whole lot of things. So let me start from the sample P, which is the ammonium sulfate. What are we expecting from here? I'll do a table too, so that you can use that as study guide too. I'll do a table so that you can use that as study guide. So let's have the test. Okay, let's have the test. Let's have the observation. Let's have the observation, and let's have the inference. That's how your table is going to look like. Okay, now please pay maximum attention. I'm going to be revealing a whole lot of things here, and I want you to pay attention. I'm going to be writing some equations too. Don't forget, this is a JUPEB exam, okay? And it's a bit of an advance, right? It's a bit of an advance. So you have to know every details. Simple details here count. So for number 1, please take your pen and jot as much thing as possible now. For the ammonium sulfate salt, which is the sample P, right? Which is the sample P. They can ask you, first thing they can ask, let me just say, they can ask you to take sample, small sample of P. Don't forget, that's ammonium sulfate. Sample of P plus it. They can ask you to put small sample of P. You take small sample of P with a spatula and eat it. Yes, they can ask you. That's the first thing that can be done here. They can ask you to take small sample of P. You get that now, and eat it. So when you eat it, what happens? When you eat it like that, the observation you are going to actually notice is that a colorless gas with a choking smell, a choking smell, which turns damp litmus, which turn damp litmus blue, right? And if you have that, I'll tell you the reason why it is like that. That's why I want you to pay maximum attention to this. A colorless gas with a choking smell, which turns damp blue litmus, sorry, which turn damp red litmus blue, which turns damp red litmus blue. From that, a colorless gas with a choking smell. Don't forget, the gas that has a choking smell is ammonia, right? So we can say that ammonia gas from ammonium ion, very important, ammonium ion present, right? And because the gas turn red litmus blue, right? Because the gas turn red litmus blue, right? So what is that now? If you turn red litmus blue, what is that? So it means that the gas is alkaline. The gas is what? Is alkaline. The gas is alkaline, and that's the reason why it is turning the damp red litmus blue. Now, why is it like that? Let me explain here now. You are not to write this. I'm just explaining what it is like. I'm just explaining this. So let me show you something here now. Let me just come. Oh, I would have. Okay, let me just go down like this, and I'll be using that. Why is it like that? Okay, let me go up so that you understand. Let me go up here. Why is it like that? Let me write it here. The reason is because we are working with ammonium sulfate, right? We are working with ammonium. Let me write it here so that you jot all these things. We are working with ammonium sulfate. Please, you are not to write it here. I'm just explaining why that reaction is like that, because this is a JUPEB exam and all this information counts. The reason is because this very particular salt, when you expose it to heat, what happens? A thermal decomposition reaction will occur. I want to believe somebody is still with me here. A thermal decomposition reaction will occur, which will give us this, H4HSO4 plus ammonia gas. Do you see that now? So when you expose this very particular salt, to heat, or when you eat it, what happens? It decomposes. And that kind of a reaction is what we call a thermal decomposition, which means it is breaking down by the presence of heat. So when it decomposes, it gives you this very particular compound, and this ammonia gas here, which is this NH3, you get that now? This NH3 that is liberated is the reason why we now have that very particular observation, that a colorless gas with a choking smell, which turn damp red litmus blue, because of that ammonia gas that will be liberated. So from the ammonium sulfate, right? From the ammonium sulfate, when you actually apply it to it, it decomposes. Okay, and that's the reason why that observation is a colorless gas with a choking smell, which turn red litmus blue. And the inference now is ammonia gas from NH4 plus, that's ammonium ion present, and the gas is alkaline because it's turning what? Red litmus blue. So don't forget, if on that day you are asked to eat sample P, the observation is this and the inference is this. Even if you did not carry out the practical, this is what the observation and the inference will be. If and only if they ask you to eat sample P. The sample P is a solid substance now. The sample P is a solid substance. So if they say take small sample of P, which is the solid, apply it, then the observation and the inference. So even the number 2 is easier. The reason is because if you perform the practical, this is what you will get. Okay, so even on that day, if you have studied this thing I'm saying very well, even if you did not perform the practical and you understand this thing I'm explaining, when you see the you can even write this without doing the practical, you will be correct. Because the theoretical knowledge is what we give the practical basics. Without this very particular thing, the practical will not be possible. So from the theoretical knowledge, we know that ammonium sulfate will decompose. and one of the products formed with the ammonia gas, and that's why you can have this observation and this inference. I want to believe this is clear. So don't forget, if you are asked to eat sample P, then this will be the observation. Now, another thing that you can be asked to do for sample P is that they can ask you that they can tell you that sample P plus distilled water, they can ask you to dissolve it in some amount of water, right? What will you get if you dissolve sample P? Don't forget sample P is ammonium sulfate. One of the things you will notice is that it will dissolve completely because ammonium sulfate salt is a soluble salt, very soluble in water. Okay, so when you dissolve it in water, so which means that if they did not ask you to eat sample P directly, they ask you to dissolve it in water. What is the observation you are going to get? The observation will be it will dissolves completely in water to form a colorless solution. Yeah, because it's around a white color, to form a colorless solution. So don't forget, if you dissolve sample P in water, it will dissolve completely to form a colorless solution, right? Very important. And if you have been following my channel, you should know the inference by now. What will be the inference if it dissolves completely in water? Then we can say sample P is a soluble salt. I want to believe this is very clear. Sample P is a soluble salt. So very easy. If you are dissolving it in water in your various JUPEB center, if you have all this salt, just practicalize this thing I'm saying. When you practicalize it, you are going to get the same observation, and you are going to get the inference will lead you to the observation will lead you to what the inference is going to be. So you can perform these two in your various JUPEB center. You see, this is exactly what you are going to be getting. So don't forget, we have talked about the sample P plus heat, the observation, you have written that, the inference, you have written that. Okay, now we are saying in some cases or somehow the question can come like we should dissolve sample P in some amount of distilled water or water. It dissolve completely in water to form or to give a colorless solution. Now we can now say sample P is what is soluble in sample P is a soluble salt. The reason is because it's soluble in water. Now, another thing they can ask you, after you have dissolved it in water, right? They can now ask you to test plus with litmus paper. They can ask you to test with litmus paper. That's the solution now. After you have dissolved sample P in water, they will now ask you to test with litmus paper. When you test with litmus paper, it's going to turn blue litmus paper red. It's possible, and I will explain why it is like that. Those equations are important. Sometimes in some JUPEB exam, they can ask you to write the equation of why it is like that, so you have to understand. So if you turn blue litmus paper red, it means that solution of P is what is acidic. Okay, now if it turns blue litmus, and I will explain why. Why is it like that? Let me write the question here again. Please jot all these things, very important. Now, for that very particular analysis comes from the topic we call hydrolysis of salt. This is just an explanation, hydrolysis of salt. And the salt is ammonium, okay, ammonium sulfate, right? Now, if you dissolve ammonium sulfate in water, okay, if you dissolve it in water, what will it give us? It is going to give us, let me say plus, let me write plus water, so this is what it will give us. What will it give us? It will give us our H2SO4, okay, plus NH4OA, that's ammonium hydroxide. This is what it will give us. This is the two solution. Now let me balance it for, you can be asked all these things. So 2 will be here. I'm just showing you the reason why it is like that. Then 2 will be for water. Now, if you look at this, Don't forget, this is the salt we are working on. When we dissolve it in water, this is the reaction that is going on. Now look at this. H2SO4 is what? Is a strong acid, right? While ammonium hydroxide is a weak base. So the reason why the solution is acidic is because for H2SO4, let me explain in a layman language, the strong acid will overpower the weak base. Let me explain in a layman language now. Because this is a strong acid, H2SO4 is a strong acid, this is a weak base. So what happens? The H2SO4 will overpower the weak base. So in an hydrolysis of salt, where you have a strong acid and a weak base, the solution will be acidic. In an hydrolysis of salt, where you have a strong base with a weak acid, the solution will be what? Will be basic. You see that now? In an hydrolysis of salt, where you have a strong acid and a strong base, the solution will be neutral. Look at this. Let's take, for example, I'm doing a reaction of sodium chloride. The hydrolysis of this one plus H2O is going to give me NaOH plus HCl. Look at that. It's going to give me NaOH plus HCl. Do you see that now? NaOH is a what? Is a strong base, right? HCl is a what? Is a strong acid. Do you see that now? Which means when I dissolve sodium chloride in water, what happens? That the solution will be neutral, because this is a strong base, this is a strong acid. The both of them are strong, so they will neutralize themselves. It will be neutral. Which means at home, the salt I used to cook is sodium chloride. If I put it in water and I test with blue or red litmus paper, it will not change. These are practical knowledge. So the theory will help us understand what the practical is going to look like. I don't know if that's clear. So the reason why the sample P, right? The reason why the sample P is now turning blue litmus paper red is because in the hydrolysis of the salt, you're now going to have a strong acid with a weak base. Thereby, the strong acid will overpower the weak base, thereby turning the solution to be what? Be acidic. I want to believe that is clear. So, if you put it in water, you dissolve it in water and you test with litmus paper, and because it is JUPEB exam, they are not going to tell you to test with either blue or red. When they say test with litmus paper, you have to test with blue and you have to test with red. So note that if it has effect on red, it cannot have effect on blue. And if it has effect on blue, it cannot have effect on red. And if it doesn't have effect on blue or red, it means that. But for this, the solution is going to be what? To be acidic. I want to believe this is clear. Yeah, I want to believe this is clear, and I want to believe you are following me and you are jotting a whole lot of things. That's why I'm writing all this reaction by the side. Yes, that's why I'm writing all this reaction by the side, so that you understand. So don't forget, we have talked about if they ask us to dissolve sample P in water, okay, it's going to dissolve completely, okay, to dissolve completely to form a colorless solution. They will say the salt is soluble, right? And if they ask us to test the solution of P with litmus paper, it's going to turn blue litmus paper red. They will say the solution of P is what? I want to believe this is clear. Okay, now, after we have dissolved it in water, we can now be asked, that's why I'm even writing the table. We can be asked again, we are still on sample P. Don't forget now, we are still on sample P. So we can be asked to divide the solution of P. That's after we have dissolved. The reason I'm using the solution is because we have dissolved it in water. So you can be asked to divide the solution of P into, let's say 2. Yeah, let's say 2. Let's say 2. Now listen to this, please. Listen to this, please. Listen. So we can be asked, after you have dissolved it in water, we can now be asked to, divide the solution of P into 2. Now, let's take, for example, the first portion. We have divided into 2 now. That's the solution of P. The first portion of solution P plus sodium hydroxide. Now listen, if one of the way they can ask you to test for ammonia gas is this first one I did by just eating the sample directly without dissolving in water, right? But they can still ask you to test for the ammonia gas by, first of all, to the solution of P, you add sodium hydroxide. That's aqueous, sodium hydroxide. if you add sodium hydroxide to the portion of solution P, what you are going to get is you are not going to see a visible reaction, and I'll tell you why. There will not be any visible reaction. There will not be any visible reaction. I'm talking from experience now. There will not be. You can try this in your various center if you have this sort. There will not be visible reaction. Now, the visible reaction will now occur when they now ask you to eat it. You see that now? When they ask you to eat it now, that's when the ammonia gas will be liberated. And I'll tell you why. So if they now ask you to eat it, you are not going to have a colorless gas with a choking smell. You can see that now. With a choking smell, turning damp red litmus blue, right? So from there, we can now have our ammonia gas from NH4 plus, right? And we can now say the gas is what is alkaline. If you look at this, it's the same thing, like it's the same observation. Is the same observation and inference with you eating directly. So if they ask you to test for the ammonia gas, they can ask you to eat sample P directly, or they cannot ask you to add sodium hydroxide. Why is this like this? You know, I'm providing you with the equation so that you understand all these things. Yes, I'm providing you with the equation so that you understand all these things. Why is the equation like that? Let me show you here. The equation is like that is because one of the property of a base is that when they react with ammonium salt, they are going to liberate salt, water, and ammonia gas. Let's take, for example, in this case, the salt is this NH4 2SO4, that's ammonium sulfate, right? Plus sodium hydroxide. Is that okay? It's going to give us Na2SO4 plus H2O plus NH3 gas liquid, right? So now look at that. So when I add sodium hydroxide, do you get that? When I add sodium hydroxide, the reason why I'm not seeing a visible reaction is because this reaction is very slow. So what happens? That's the reason why I'm now eating. When you eat it, it becomes faster and it will be liberated. Let me balance the equation. You can be asked to write all this. It's because it is JUPEB exam, that's why I'm providing all this. You can be asked. So this very particular ammonia gas here is the one that is liberated, that is now giving us a colorless gas with a choking smell, turning down red litmus paper. You get that now. Very, very important. And they can ask you, what is the confirmatory test for ammonia gas? The confirmatory test of an ammonia gas is that you bring it very close to the stopper of concentrated HCl. When you bring it, it is going to form what we call, when you bring it very close, like the NH3, if you want to confirm it, they can ask you that least one confirmatory test for ammonia gas you can be asked. So when you bring it very close to the stopper of a conch H2SO4, it formed this NH4Cl. And that's why we are going to have what we call a white dense film. That's what will be formed. It's even one of the video I did. I think, yes, it's one of the video I did. It's on the channel where I showed this practically. So a white dense film will be formed. A white dense film. So that's a confirmatory test for ammonia gas. When you bring it very close to the stopper of a conch HCl, it's going to form ammonium chloride, which will be characterized by a white dense film. So understand it. So for sample P, you can test ammonia gas in two ways. It's either you eat directly, the salt directly, okay, or you add sodium hydroxide and you eat. Now listen, if on that day you see all these things, you are not, even if you are not doing the practical, your test and your inference will be correct. Because on that day, if you just see sample P plus NaOH, no visible reaction, plus it, a colorless gas with a choking smell, turning damp red litmus paper, a smart JUPEB student should be able to do the number 2 comfortably, because I'm going to provide you with every details to the last. So carefully, I hope you are jotting something. I'm going to provide you with the last details, the equations, why it is like that, so that you understand it. When you understand it, and you see the questions on that day, then you can apply this thing you have learned here. So what you are watching out for basically is the test. We know that anytime P reacts with sodium hydroxide, no visible reaction, then we eat it, it will give us this, right? We know that when we dissolve P in water, it will give us this, it will give us that. We know that when we eat P directly, it's going to liberate ammonia gas. Very simple question. Very simple question. So that is what you can be asked for as regards as sample P is concerned. As far as sample P is concerned, don't forget I said we are taking an assumption now. We are assuming now. Don't forget, we said we share the solution of P into 2. So let's use the second portion now. So let's say second portion plus barium chloride, because it's part of the reagent they ask us to provide. When we see this barium chloride, we know what they're asking. So if you take the solution of P, we said probably they said you divide into 2. You see the solution of P, okay, and they ask you to add barium chloride. They ask you to add barium chloride. What will you get? You're going to get a white precipitate formed. A white precipitate formed, right? When you have a white precipitate formed, what are the ions that are present? You have CO3 2 minus present, or SO4 2 minus, okay, or we have our SO3 2 minus present. These 3 ions will form white precipitate with barium chloride. Now listen, now look at this. Don't forget P is what? Is NH4 SO4 2, right? What about Q? FeSO4. What about S? CuSO4. Now look at the cheat now. For any of these salts, any of these 3 salts, if they ask you to add barium chloride, it is white precipitate that will be formed. So not even only on P. If they ask you, just check the test. Check the test. If the test is add barium chloride to any of the salts, any of those 3 salts, you are adding barium chloride, the observation is that a white precipitate will be formed. Then the ions will be CO3 2 minus, SO4 2 minus, or SO3 2 minus present. That's the cheat. Oh, I want to believe somebody. Chemistry is sweet. I want to believe somebody is here. Now, after this, they will now say followed by dilute HCl. Any. When you add dilute HCl, what you are going to notice is that the precipitate will dissolve. The precipitate will dissolve. Do you get that now? The precipitate will dissolve in dilute HCl, right? It will dissolve. And when it dissolves, it means that the only ion we can now infer from that is this. The reason is because in dilute HCl, your SO3, do you get that? Your SO3 is precipitate insoluble, sorry. Precipitate insoluble, sorry. Insoluble, sorry. It's going to be insoluble. So precipitate is insoluble in dilute HCl, meaning the precipitate will not dissolve. Do you get that now? So if the precipitate dissolves, it will mean that it is SO3 2 that is present, or CO3 2, because your CO3 2 minus and your SO3 2 minus is going to dissolve if you add dilute HCl. But since it did not dissolve, so precipitate is insoluble. Since it did not dissolve in dilute HCl, it means that SO4 2 minus is present. Okay. So for any of these 3 salts, when you see add barium chloride, is white precipitate that will be formed. CO3 2 minus, SO4 2 minus, or SO3 2 minus present, followed by dilute HCl, the precipitate will not dissolve. Okay. The precipitate will be insoluble in dilute HCl. And when it is insoluble, it is SO4 2 minus that is present. I want to believe this is clear. So note this. In fact, if I were you, I will study this well. And from the test, you will know what the observation and the inference. That's why salt analysis is very simple. When you have a channel like this that can explain all this for you, it's a plus. It's a plus because it is easier. It is much more easier because that reagent will tell us the observation and will tell us the inference. So not any of the salt, either P or Q or S, you are adding barium chloride to them, it is white precipitate that will be formed. When it is followed by dilute HCl, the precipitate will be insoluble in dilute HCl, the precipitate will not dissolve. And from that, the inference will be SO42. That's all what you can be asked as far as the first sort, this is concerned. This is concerned. Because it's either you are testing for this or this. So for the sample P, all what you can be asked is what I've stated. So please take your time to study this. All what you can be asked is what I've stated. But they might not ask you up to this extent, but you know, I'm just doing this so that I can have a broader knowledge of what it is like. I want to believe you are still together. Okay, so that is for sample, that's for sample P, which is ammonium sulfate. That's for sample P. So let me analyze your sample Q now. Your sample Q. Let me analyze sample Q. So let me just call that B, because that's, so let me still rule. Don't forget we are still on, let me write it, we are still on our test, still test, observation and inference, still test. So still test, okay, this observation. If you are just joining the channel, please go and start from the beginning so that you understand what we have been doing. Okay, take your time to. So I'm done with sample P, right? So let's talk about our sample Q now. What happens? Sample Q can be asked that we should dissolve in water. Very, very likely. It's very likely. Plus distilled water. And don't forget our sample Q, that's iron 2 sulfate, and the color of iron 2 sulfate, because most times you are going to see it in the hydrated form anyway, is a light green. You are going to see it in the hydrated form. I think this is one of the ones you cannot get the hydros. It is very hard to get the hydros. You get the hydrated one, so it is a light green color. So when you dissolve it in water, it dissolves. It will dissolve completely. It will dissolve completely in water. Please note all this. You dissolve completely in water to form a light green solution. To form a light green solution. Because that's the color of the hydrated iron 2 sulfate. So if it dissolves like that, we should know that the inference, it means that our sample Q is soluble in what? In water. So take note of that. Your sample Q, iron 2 sulfate, if you dissolve it in water, it's going to dissolve completely to form a what? A light green solution. And now, if you now test the solution with litmus paper, let's see that from the theoretical knowledge, let's see what is going to give us. What is our iron 2 sulfate? What will it be like? Okay, the iron 2 sulfate plus water. Let me write it here so that you see. When you dissolve this plus water, I'm writing the equation because JUPEB, they are very funny. They love equation. My brother, they love equation. That exam, because it will give this. And I think I've said that. Let me balance this equation. 2 is going to be here. So I think I've said that earlier. Look at this. When you dissolve the iron 2 sulfate in water, it's giving us H2SO4 and iron 2 hydroxide. H2SO4 is a strong acid. Iron 2 hydroxide is a weak base. So definitely the solution will be acidic too. So which is the same with, you can see the knowledge I'm using for the analysis. So which is the same too. Which is the same. So it will turn, if you dissolve it in water, if you test it with litmus paper, it's going to turn, the solution will turn blue litmus, paper red. So it means that the solution of Q is acidic. I want to believe this is clear. Okay, the solution of, so after that, we can now be asked to divide the portion into 3. That's the solution of what now? The solution of Q now. We can ask to, divide into 3. So let's see the first portion. The first portion of what now? Q, right? Okay, Q plus sodium hydroxide aqueous. What will it give us? Please note all these tests. What will it give us in drop and in excess? In drop, you can say in drop, sodium hydroxide in drop and excess, or they just say sodium hydroxide. What will it give us? It's going to give us a dirty green gelatinous precipitate. Do you get that now? It's going to give a dirty green gelatinous precipitate. So even in excess, insoluble, it will be insoluble. It will be insoluble in excess sodium hydroxide. To be insoluble. Even if you have sodium hydroxide in excess, it's going to be insoluble. And from there, the color, when you see the green color, then we know that it is ion 2. That is what is present. I want to believe somebody is there. So if you study this thing I'm saying well, you should know how. In fact, the number 2 will be the simplest. I tell you, the number 2 will be the simplest. That's the first portion now. If you take the first portion, you have sodium hydroxide. Please, if you have this sort in your various JUPEB center, you can try this out. Try this out and come and give us comments in the comment box section of, how the practical looks like, and if it is the same with all these analyses. Definitely it's going to be the same if you have practicalized it well. So the first portion of Q plus sodium hydroxide in drop and in excess is going to give us a dirty green gelatinous precipitate. Even in excess, it will be insoluble. And from there, we can say ion 2 is present. Please note the valencies of those ions. There is difference between ion 2 and ion 3. This is ion 2, right? So please note that. So if they ask us the second one, we can say, okay, the second portion of Q plus, can we ask to add ammonia? Do you get that now? Ammonia 2 in drop and in excess. If you go and check what I displayed earlier, you will see at the bottom of the instruction, there are reagents they want us to use. And you see at the end of this video, I would have used all those reagents, which means this thing I am saying here is 75% correct. It's 75% correct. So ammonia in drop and in excess, right? Is still going to give us a dirty green, still same thing. It's going to give us a dirty green gelatinous precipitate. Insoluble in excess ammonia. Do you get that now? So don't forget, anytime you have sodium hydroxide or ammonia reacting with what? A solution of sample, a solution of Q. Don't forget our Q is iron 2 sulfate. The same test, the same observation, then we are going to have the same inference. So either the solution of your sample Q is reacting with sodium hydroxide, you have to add either sodium hydroxide or ammonia. You're going to have a dirty green precipitate insoluble. Okay, and we have iron 2 present. There is one which is very sure. I'm sure of this, guys. So take note of this because it is in the reagent that you are going to use. They practically specified it. So this one is sure. I'm 100% sure of this. So they can ask us third portion or any portion of solution Q plus potassium hexanoferrate 3 solution is there. It's part of, if you go and check what I displayed earlier, you will see there is a potassium hexanoferrate there. So if you add this in your center and you add it, you are going to have, the observation is that you are going to have a dark blue blue. Now listen to this. Very, very important. You need to understand all these things. Yes, you need to understand all these things. If you most of the time, what happens is that a lot of us, maybe because of how expensive the reagent is, we are not actually able to get it. Okay, but these are, if we can get it, it makes a whole lot of sense. I tell you, it's going to make a whole lot of sense. A whole lot of sense. So if you add this, a dark blue precipitate, a dark blue precipitate is going to be formed. Yes, a dark blue precipitate is going to be formed. Sometimes it looks like, from experience, I think I've done this once. The test for, because it's a confirmatory test for ion 2. Yeah, it's a confirmatory test for ion 2. Yes, the confirmatory test. I think I did it once. So it's either you are having a dark blue. Some people recorded a blue black. Some people recorded a Prussian blue. Let me write it. Anyone is correct. Anyone is correct. It's either a dark blue. I remember then some people recorded a blue black. Some people recorded a Prussian blue. A Prussian, Prusin. Anyone, but I just love to be simple. I recorded a dark blue. So, and from there, you can now confirm this, please. It's a confirmatory text. Confirmed. It's a confirmatory test. Don't write present. It's a confirmatory test. Yes, it's a confirmatory test. Ion 2. It's part of the instruction they ask your various center to provide. So note that anytime you are adding potassium hexacyanoferrate 3 solution to the solution of Q, which is ion 2 sulfate, they are going to have a dark blue precipitate form or a blue black. Or please, I did not ask you to write these three observations. I'm just using it to explain. So that you record a dark blue, just be simple. A dark blue is fine. Okay, precipitate form. I'm just talking about what others recorded when we did it then. What others recorded? Some people recorded a blue black. Some people recorded, some people are over Sabi. They recorded a Prussian blue. I'm just there. But I recorded a dark blue anyway. So, okay. So that's that. And ion 2 is confirmed. And the reason why it is like that is this. This is the reaction, please. These are JUPEB students. Please, we have to be very. This is the reaction. I think this is the reaction. If I still remember, we have ion sulfate, ion 2 sulfate, plus this potassium hexacyanoferrate. That should be Fe, right? Cn. Okay. Hexacyano-Cn. That should be 6. Okay. I think I should be right. Yeah. I think this is it. Then the reaction. I hope I am correct. We have this. We have Fe. It's a coordination complex. Anyway, it's going to form a coordination compound. Then we have 6. Am I right? Okay, 2. I think plus. I hope I'm right. I can cross check too. Anyway, but I'm just trying to provide us. I think this 3 ion. I think 3 can be here. So this very compound is what formed the dark blue. This compound, this coordination compound formed. Yeah, this coordination is what brought about that very dark blue color that we are seeing, because this is a coordination compound. I hope one day on this channel too, when I have time, I'll talk about coordination compounds. Yeah, another interesting aspect of chemistry I love so much. Yeah, I talk about ligands. I talk about monodentate, bidentate. All those things are important. Okay, don't let me digress. Anyway, chemistry is interesting. Okay, so that's the reason why we have that dark blue. So this ion 2 sulfate reacting with this potassium hexacyanoferrate 3 solution they ask us to provide is going to give this complex and this. So this very particular reaction here, this one I put in a rectangle is why we have the dark blue. So don't forget, if you are asked to add, it will be there, because I just have to provide that solution. This one will be there. So this one will be there. So just the more you quickly understand this, the better for you. So take note of that. I hope this is clear, and I hope you are following me. So that's all I can be asked as as your sample Q is concerned. And don't forget this. I have said it earlier in the video that your sample, these two, you can be asked to add barium chloride. Maybe they ask you another question if you have not forgotten. So any of the salt, any of those three salts, if you see barium chloride there, they ask you to add this barium chloride followed by dilute HCl. I think I've already talked about the observation. White precipitate will be formed. Then you have CO3 2 minus, SO4 2 minus is there. Think, let me show you again for people that might just be watching. For people that might just be watching, let me go back. This is it. So this is it. This is it. You can see barium chloride is going to form a white precipitate. You can see going to form this white precipitate, and these are the ions that will be present. But when you now follow this up by dilute HCl, you are going to have this precipitate will be insoluble in dilute HCl and SO4 So for any of the salt, and the reason is because the salt contain SO4 2 minus. All the salt they gave us, all the salt they gave you this year contain it. So definitely, if you add barium chloride to anyone, that's what it will give you. I hope that is clear. I don't just want to be repeating it so that you'll be sure you can study this over and over again. So let's take the last salt now, which is the third salt. That's what? Okay, that's copper sulfate now. So let's take the last one, which is copper sulfate salt. What are the tests we are looking for? What are the tests we are looking at, or where can we be tested on as far as that one is concerned? Please, I want to believe we are together. So please note all this. You in your own jotter, you can now make this table. From what I've been saying, you can even divide this into this and make a clean table for yourself where you can now study it over and over and over again. Okay, so for sample S, let me say C, figure 1. For sample S, don't forget our sample S is copper sulfate, right? You can see the SO4 too is there. So anytime you are add barium chloride, is white precipitate that will be formed. So note that, please. So sample S, so I'll not be repeating that. I'll just go straight to the one we have to do. Sample S plus distilled water. Don't forget the color of copper sulfate has the dehydrated. Most times I'm going to say dehydrated is blue. Yes, is dehydrated is blue. Most times it comes as dehydrated. So when you dissolve it in water, it's going to dissolve. It will dissolves completely. Dissolves completely in water to form a blue solution. Some can say a light blue solution. Anyone, a blue solution. If you are not, you can just say a blue solution is fine, or a light blue solution is fine. So because the solution, the salt is blue itself. So from there, from the inference, we can now say sample S is soluble in water. So which means that the three salts, if you are dissolving anything, they are soluble in water, or with different color. The first salt, which is ammonium sulfate, will form colorless. That's why I'm recording the color. This is a JUPEB exam. There are marks for this thing. The first one will dissolve in water to give colorless. That's ammonium sulfate. The second one, iron 2 sulfate, will dissolve in water to give a light green. The third one, copper 2 sulfate, will dissolve in water to give a light blue or a blue solution. So we can be asked to test E2 with litmus paper. Let's see. So we can have CuSO4 plus, let's see what the reaction will be, then we can have the observation. This one will give us H2SO4 also plus, going to give us copper 2 hydroxide. Right? Yes, going to give us, sure of that. It's going to give us, so we can balance this space too. So somebody should be able to tell me, you can see, this is a strong acid. This is a weak base. So which means the solution too is going to be acidic. And if it's acidic, it will turn blue litmus paper red. It will turn blue litmus paper red. Right? And from there we know that the solution of S is what is acidic. So These are things to note. The 3 salts, when you dissolve it in water, it will form an acidic solution. You can see that now. So note that the 3 salts, these are what is common to the 3 salts. When you dissolve them in water, they are going to give what? An acidic solution. And the 3 of them, when you react them with barium chloride, they will give white precipitate, okay, followed by ACl. Then we can now say SO4 2- will present, because CO3 2- and SO3 2- they will dissolve in dilute HCl, but SO4- will not dissolve. So very common to the 3 of them. So very, very important. That's one of the things they can ask us to test for. See, and they can ask us to divide the solution. Yes. So we can have the first portion of solution S now. First portion of solution S plus sodium hydroxide in drop and in excess. In drop and in excess. So that's going to give us a light blue gelatinous precipitate. Gelatinous precipitate. A light blue gelatinous precipitate, okay? Insoluble in excess sodium hydroxide. Do you get that now? Then our copper definitely is present. It's present. I want to believe this is clear. Our copper definitely is what is present. It's present. Right? So, very important. Then they can ask us that the second portion, the second portion plus ammonia, which are ammonia in drop and in excess, right? So what will that give us? That will give us, in fact, that one is very interesting because I love that. These are things I've even done for some of my students here. So it's going to give us a deep blue, very deep. It's going to give us a deep blue solution. A deep blue solution. Then from there, I can confirm copper too. That's a confirmatory test. A deep blue solution. Yes, a deep blue solution formed or observed. Then we can have this. And of course, I've seen questions like that. Why is it like that? Why do we have that deep blue? Yes. Why do we have that deep blue solution? Why do we have? Because, we're going to have around something like this. Because when you add the sodium hydroxide, do you get that now? When you add the sodium, okay, let me show you something now. The copper 2 ion, the first time I will add my ammonium hydroxide or ammonia, when I add this, do you get that? It's going to give me this. I'm providing you with this equation because JUPEB are funny. You can be asked to write the equation. I've seen questions like that. It's going to give this. Do you see that now? So this one now that is now here, when I now add excess, this one will react with excess. So when I add excess ammonium hydroxide, it will have something like this. So this copper 2 hydroxide now, which is formed from when I first of all added sodium hydroxide. You get that now? When I now add it, when I now add excess of this, that means excess of this. Do you get that now? Of ammonium hydroxide, I'm now going to have something like this. It's forming a complex 2, coordination complex. I think I will have something like this. How about this? My equations are correct. So because I'm just trying to provide us with details. Okay, so this very particular coordination compound is what formed the deep blue. So please jot all these things, jot all these things down. It's very, very important. This is why you now have that deep blue. So they can ask you to write the reaction that will come when this react to this. They can ask you. So please note all this very, very. And that's it. Please take your jotter or take your notebook or take your exercise book and prepare this table very neat in your own book so that you can study it over and over and over. If there is need for you to watch this video again, try and do it. This is 75% of what the SWOT analysis is going to carry. I can assure you that. You can trust me for that. I can assure you that this is just what the sort analysis is just like. So guys, go over this over and over and over. We have done justice to the titration and the sort analysis for JUPEB. I wish you guys good luck. So watch this over and over again. Share to your friends. If you have your JUPEB group, please share to them. Don't be selfish about this video. Don't be selfish, please. You can share to them. Let them learn too. The success of everybody is our priority on this channel. So if you have any JUPEB group, you have somebody writing JUPEB, you are a JUPEB chemistry instructor, please share to your group so that it will ease your job and all these students too can learn from it and prepare adequately for the exam. So this is Chemistry Hangout. If you are just watching this channel, kindly subscribe to this channel and turn on your notification bell so that when we upload any video, you are going to be notified. So this is 2024 JUPEB, chemistry practical questions, well explained, sorted, demystified to the best of my ability. So guys, watch the video, share it, comment. If you don't have that link, I've told you, check the comment box section. I'm going to drop some link there to some of the the videos, 2022 video that will guide you for titration. And if you don't have the site for JUPEB that you can get their past question, just drop a comment so that I can send it personally to you. I love you guys. I wish you tremendous success in this year exam. So do justice to this. You too, write out all this, watch this video over and over and over and over again so that you can get the analysis. God bless you. Wish you guys success. Thank you and bye.